Try a marker.
Yeah,
Oh, this is weird.
Green and juice.
Jinxing is not possible, by the way. I mean, higher derivatives. You've got a little intro to this already.
Did we? Oh yeah, we did. I'm not paying attention.
Pretty sure that's now all published to YouTube, so. There you go.
Donald Trump is my savior.
I just got a bunch of haters.
Don't worry, don't get any views. That's all good.
Oh my goodness.
I get enough views.
7.
I had lost these cards.
Okay, so the point of higher derivatives is can you keep calculating derivatives? Right? Now they can get pretty nasty if you have a product rule and then you have another product rule and they start stacking product rules and quotient rules and all sorts of stuff like that. Okay.
Does not sound good.
So how many derivatives is this?
3.
Yeah, 3 derivatives. Triple prime.
Prime time.
Yeah.
Is there any more than that?
Yeah, so we can. So if you want notation, you have f prime of x. Right? What's f prime of x for that function?
Well, Q minus this.
Okay. Anybody disagree with that? Okay, good. Okay, f double prime.
Switch to it. 36x.
Whoa, okay.
All right, you just keep going. And then you got f triple prime. Okay, and I'm going to tell you right now, I'm looking at your homeworks that I grade. Your notation is awful. And this is kind of stuff is where if you don't write f prime and f double prime and f triple prime, if you don't write those down,
You don't get
we have no idea what you're talking about. I think I could probably figure it out. Okay, but it's your job to tell us what you're doing. Okay? So what's f triple prime of x? Okay. Can I keep going?
Yeah.
Oh yeah, I could do, this is how we know. That's how we know higher derivatives of derivatives higher than 3.
Wow.
Weren't you saying how they use like 0?
Yeah, there are definitely scientists out there that think they're really cool that have used the 9th derivative for something.
That does not
Do I
sound.
care? Not really, but I don't know.
It
That's what I
sounds
said. I don't know. I
awesome.
didn't look
So you
into it.
just casually sit down one day, yeah, I want to calculate the 9th derivative. Sounds like a
No, it's physics, and it has to do with dimensional
Sounds
physics.
like a cool idea.
You know, what's the 5th dimension? Okay, so what is f triple prime at -1? Yeah. Good. There you go. Okay, that's pretty straightforward first, second, third derivative calculation with the
That's not bad.
equation. Now I say it can get pretty nasty, right?
Yeah.
Because you can bring in a product rule, and then the second derivative of the product rule is going to be another product rule, probably 2 of them. Do you want me to show you one?
Yes.
Yeah.
New page. Okay. Let's call the function.
Oh, great.
Yep. I agree. It's pretty cool.
No.
Okay, again, you're asked to calculate the derivative. What rule are you going to use? That's the biggest thing people struggle with. Yeah, it's a product, so we use the product rule. Okay.
Yeah, it's
Okay. Yeah, derivative first,
so it's 2x.
copy second.
Yeah.
I did see issues last Wednesday on the card, index card we did, or the There was an index card, it's a sheet of paper.
Oh,
Derivative, copy, plus, copy,
Derivative.
derivative. Derivative of e to the x is
E to X.
e to the x. It's the most simple one we have.
Yay.
Please remember that. What's funny? Did I do something funny? He did something. That man has done some pretty funny things in his life.
I have? What do you mean?
I just won't mention it.
Yeah,
You were
it's
club
basically
candy or anything.
I need to tell me what you did.
No, it's
Not right now. Later.
No.
You're a junior, right?
Yeah.
You guys have to let me speak at your graduation so I can tell you what you did. No, I'm still not going to tell you. Okay, second derivative. How do you derive that?
Oh my
It's a
God.
product rule. And this is another product rule.
I'm smelling.
It's not stupid, it's just what it is.
It's not pleasant.
Product rule and a product rule, right?
Product rule.
So let's color it. What's the derivative of this one? Derive, copy, plus,
Okay.
copy, derive. Right?
Plus, right?
Okay.
Wait, you sure?
I can't
Cool.
get it.
Are we good there?
No.
Oh. Wait.
That's just this one.
And then you plus it.
Plus,
Would you put it in parentheses or not? Oh,
Can we put it in parentheses?
you don't need to because it's all pluses. If there were minuses, you would need to. You could. No, that's fine. I don't care.
Pull another one
It's
out.
not necessary. It's more work. Do you like to do more work?
Can you pull me out of another one?
I don't like to do more work than necessary. Okay, that is another product rule. And guess what? It's the same as the first one, right?
Yes.
Same function, so we can just copy this down if we want. So it's copy, the derive, copy, plus, copy, derive.
Oh.
Hey, you want to do a third derivative?
No.
Come on, it'll only have 8 terms.
No.
No thanks.
Okay, so you get the idea though, right?
Yes.
You can do the same thing with a quotient rule.
Is there any way you can? No.
Yeah, it'll no longer be water. Well, you'll just have to-
Okay, we can combine like terms. It's a good question. 2xe to the x, right? And a 2xe to the x.
2x to the x, please.
No, we're adding
So it's 4.
Four.
4.
xe to the
Like
x's.
you're actually doing it?
Oh, it's just 4.
2 and 2 is
Oh.
4. It's like apples and apples, right? Can I combine the others? No, I can't. Those are oranges and apples now, right?
Wait, how did that? Oh.
How'd that happen?
That might be magic.
Match.
Welcome to calculus. Okay, so a couple solid problems.
This is fun.
Are we good?
No.
Shouldn't you put F prime as equals?
Good point. Do I need to?
Yes.
Is it no?
Don't you need
Is
to?
this enough?
No.
This is something that I've seen pop up a lot. This, and then you put an equal sign below it, implies that that follows.
Oh, okay.
Okay?
So like, no, the same thing.
Yeah, it's a subject relationship.
Yeah, that's what I'm saying.
Subject-verb relationship. You define your subject, you don't need to worry about it. Now, here's where a lot of you are getting in trouble. Side note.
Side note.
I saw that on the homework I graded yesterday a lot.
Yeah.
Is that a true statement?
No.
No, it's not. Don't do that, please. Is this correct?
No.
No, because x squared does not equal 2x. Okay, you have to do that. Well, you don't have to. You can get it wrong if you want.
That one?
But I totally am not okay with that. I hope you aren't either.
Doing all that work
Okay.
just to get it wrong.
Notation is
Notate
key.
it right.
Keep things straight. Okay.
I don't tell.
You get a 4 because there's one question you didn't make.
And you're like,
All right. Oh, this is a physics problem.
Hey, can we just do this middle line?
Okay.
I
Real quick. Okay, do you know
I dropped out of physics.
the position function for gravity?
Oh, yeah. I know.
Okay, a lot of times, you know,
4.9 now?
yep, it's more. Keep going.
I can't remember. 4.9 t
Negative.
plus negative 3 minus 50?
And then, okay, this is straight up and down. If you get an angle, like you guys are doing physics catapults and stuff right now, right?
Yeah.
If you put an angle in, there's a sign in this. Sign for angle compensation. This is just straight up and down gravity falling objects. Boom. Okay? That is the initial velocity. And this is the initial.
Because I decided my business classes.
Does that say HO?
Yep, H sub 0. H sub
0.
0. Because it's subscript. And you have V sub 0. Oral combat.
And that's gravity.
Negative. No, but it's always.
Okay, you good with that? Okay, so let's say you're being dumb.
Oh, goodness.
There's a stupid person at the top of a cliff. Hey,
Oh, they're
stick
gonna
man.
jump off.
And he drops a rock.
Oh.
But he is kind of smart and he goes, rock!
Voice people.
Okay, initial velocity, 0 because you just
Drop it.
dropped it. How high up are you?
Oh, how high?
150. 150 meters, that's a long ways.
That's a long ways.
I would definitely go.
So our function is, correct? What is the velocity at any given time? Yeah. At any time, the velocity is the derivative of the position, right? The position function, that's where the rock is. Okay, the derivative. Well, you can also know that velocity, this is perfectly acceptable, either one. What's the derivative of that function?
Negative 9.8 t. Okay.
What does that number represent? Acceleration due to gravity, right?
Yep.
Okay. And then what is the acceleration? Is the second derivative. Or the first, the derivative of velocity, or you could call it a of t, I don't care. Acceleration due to gravity. Okay, so any one of these three works. You don't have to write all three of them. Any one of them works. Any two of these work. So can you calculate velocity at time 5?
Yes.
Yeah, velocity at time 5, plug 5 in, you got your answer. Okay. Makes physics a lot easier, doesn't it?
It's not even on there. I know it.
Definitely. Because the algebra behind that is very difficult. No, it's not difficult, it's pre-calculus, it's just a lot of it.
It's just
Okay? Are you okay with that?
yes.
Get used to this relationship. It's big.
Just the bottom half.
Okay. Ha!
You had to say something.
He is funny.
You know me better than that.
I should have this.
Wow, Brandon, way to throw some shade.
He's never here.
Prelim.
That's a lot of.
Things.
Okay, there you go. So you have prelim 4, and then here are your exercises. They're not very difficult, most of them. It's practicing derivatives. So today's a lot of practicing derivatives. Okay, and then, yeah, I know, trust me. Tomorrow, is that too much work?
Yeah, that is a lot of work.
I could get very overwhelmed.
Yep. It's just this note. Okay, there you go. Slim down version.
Thanks.
Focus on practicing your derivatives.
Okay.
Okay, that's it. Hey, we made it.
Play higher by 3.
Yeah, it's a note that I ignore most of the time, actually. There are always fun calculus things that we can do, and then I just kind of...
I need to just kind of don't want to do them.
Oh, and we're still online, so...